right. Right. Good morning, everyone. So I warmly welcome every one of you to the seminar on geometry and theorems. Before starting off with, I just want to confirm whether my microphone is, the voice is clear, and also the video is fine. Everyone can see. Please leave a message on the chat box, right? And also I have a whiteboard behind me, and I hope it's clear. If it's not, please. All right. Okay. Thank you. Okay. So for those who are joining with me as the first time today, just to introduce myself, I'm Sayyaf Ahmed. I'm from Colombo, and I'm basically a financial consultant running my consultancy firm on accounting and finance. And when it comes to my lecturing history, I've been lecturing for like 9 to 10 years for maths, accounting, economics, and so some professional qualifications, right? So we thought of conducting some free resource or free seminar series because of this pandemic, and also to benefit the students island-wide, because this pandemic has made everyone difficult. So there are many chapters remain uncovered in the school because of the pandemic. So, and also students having some during some issues. So this is actually a 10-day program where I used to conduct every year. Like, this is a 10-day series where I have combined 2 series per day and conducting online this time free of charge the people, right? So I hope most of you were participated to the seminar earlier on, pre-seminar on sets and probability and the stuff. So today we will be starting off with the geometry and the theorems, right? I hope everyone has downloaded or you have received the note, right? And the tude consisting of 20 pages. Okay, so if not, you can download from the link I have shared with you guys, right? Also, those who are live from YouTube, right, please make sure that you are attentive, and also there might be a slight time difference between the actual time and the YouTube live stream, about 20 to 15 seconds. Cool. So to start off with, let me share. So the session is going to be like, I will be explaining some question on the whiteboard as well as screen sharing. So the note I have given to you, the tude you all have now, is comprised of grade 9, 10, and 11 syllabus related to geometry and theorems. The only or the main reason why we have chosen this as a free seminar, because there are many requests from students, right, that this particular geometry or the theorem questions are a little bit difficult, or it's kind of complicated questions are in the past papers. It is obvious because uh, the theorem is starting actually in grade 7, 8, right, axioms, and then keep on you studying in grade 9, 10, and 11, where you are required to have a complete knowledge on your theorems to answer a particular past paper question. Because if you look at your past paper, in your part 2 paper mainly, if I talk about, in the section B, out of 6 questions, there'll be 2 questions mainly on this particular area. I mean the geometry and the theorem, where the examiner forces the student to do at least 1 question. So there are 6 questions, so you must do 5 from the part B. So that means every single student who is participating or who is writing for whatever is a must to attend at least 1 question on this area. So we never know which one will be tested, but if you look at your past paper throughout, right, the past paper questions are not directly asking or directly testing a particular theorem, even though there are like 30, 35 to 40, 45 theorems in your syllabus, starting from grade 8, 9, and 10, especially from 10 and 11, right? So there are like 40, 42 theorems, right? So the past paper question is not straightforward when it comes to this chapter, right? When it comes to percentage or any other chapters, the past papers are quite straightforward, but the examiner makes it a bit complicated to test your knowledge. So, and also they have made it compulsory to at least to attend 1 question, is because in mathematics, the geometry is one of the most important areas. So without, we would say, without geometry, maths paper is just nothing, right? So to start off with, right, if I hope you guys have this particular note with you, okay, right. And when it comes to the geometry and the theorem areas, right, here I have listed your grade 9, 10, and 11 chapters, chapter-wise headings, right? Like you will have in grade 9, 10, and 11 textbooks. And I have carefully prepared this particular tude to make sure everything covers, nothing is missed out from your grade 9, 10, and 11 syllabus. So this is going to be your summary version of what you have in your series, right? So a student revises this particular tude thoroughly, and together with the past paper practice, will definitely be able to answer both questions in the past paper. So even since I have been involved in the past paper, the paper correction, we see many students skip one of the geometry or the theorem question in the past paper or in the paper B section, right? But I want to change that, because every student feel that, or most of the students feel that this is difficult. It's not. If you have the right knowledge, and because different student will look at a question in a different way, right? So the examiner asks it from a different angle. So what is to be bridged is the gap between the way you think and the way the examiner thinks. So when it comes to these areas like the triangle, parallelogram, right, congruency, chords of a circle, angles in a circle, midpoint theorem, so and so forth, and until the tangents, these are topic-wise headings that we will be covering throughout today as a revision, right? So if, yeah, to just to start with, let's look at your 2017 past paper. If you look at your 2017 past paper, right, and you have a question on geometry in the as a question 9. So if you look at the question 9, it is a theorem related question, right, where just a paragraph and a diagram given to you. This is for a 10-mark question. And even if you look at the question number 10, you have a triangle related. So here, the most important thing that you need to understand is show that this kind of question requires a theorem to be proved. But examiner is very rare to test a straightforward question in terms of your past paper. So be confident that at the end of the session today, right, you must be able to answer this question. Have that faith, have that confidence, and let's start, right? And even if you look at your 2018 past paper, right? And we can see there are two questions. Apart from the part one, I just forgot about the part one, still there are questions. If you look at your 2018 past paper, right, we have question number 12 and question number 9. So likewise, you will have, even if you look at the 2019 paper, it is the same scenario. So I want you guys to be with me until the end of this particular session, and let's cover the theoretical areas and to at least practice few questions, right, if the time permits, because we have a limited time, and I will try to cover this area as well as the constructions, right, to benefit everyone. Cool. So I just want you to have a notebook and a pen, right? Because we are not going to draw anything because of the time constraints we have. But yeah, I want you to be attentive, right? Okay. Even if you look at your 2019 past paper, 2019 past paper also has a particular question on this area, right? You can see question number 12 and the question number 9, right? So it is clear that everyone must at least answer one question in the past paper, right? Okay, so you have like more than 25 days for your exams, right? So the 1st of March, the exam is starting on. So we have more than enough time for you to practice this question on this, right? So what is lacking is just to cover the area that you have not covered at school or in other classes, right? So make sure you are attentive throughout the session. And if you have any question, I will allow you guys to Yeah, so someone says the voice is clear and the video, yeah, so fine. I hope it's clear. If it is not clear, just let me know. Yeah, so then I will allow you guys to put question on the chat box, right, when the time comes. And also, right, guys, so to start off with, right, the congruency of triangles. So this is a chapter that you studied in grade 10, where you have the congruency. What is the meaning of congruency? It is the coincidence, or we say similar triangles which have the same elements, right? Say for example, if there are two triangles and they are, one can be placed on the other, which means they are congruent to each other, right? So when it comes to your syllabus, right, we use three cases or four cases to say that two triangles are congruent to each other, right? And also, guys, if you can't see the shared screen, just let me know, right? And drop me a message. So basically, what is a triangle then? So triangle is a plan figure. It has three angle and three sides. So I just don't want to go line by line, guys. Then it will be boring. I just want to give you, I'll pass my knowledge to you guys, right? I just don't want to waste the time in just answering, like reading the line by line, because already you guys have the note with you, right? Okay, so when two triangles are congruent, right, we have to use at least one of the cases of SAS, SSS, AAS, and RHS, right? And right, so to start with the cases, right, now what are these cases? Now why it is important? Now when it comes to a question on congruency, it is very important to say under which case these two particular triangles are congruent, because for that case, mentioning the case in your answer, examiner is giving you one or at least half of a mark, which is very much significant, right? So that means you need to understand or identify under which particular case, whether this is SSS or SAS, right, or RHS, is very much important, right? And also you will have to use these kind of congruencies when you are proving a theorem in a part 2 question, right? So if it is a triangle related theorem question, most likely, if you look at the past papers, right, majority of the question have come using a theorem related with including or with linking a congruency, right? You must have done past papers by now, and if you are not done yet, and also I see there are many students have skipped these questions and keep going on, right? And they have gone. So go back to the past paper and let's revise with this knowledge. Okay, so if you look at the SSS, this is very basic, right? Where we have side, 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 where the side or three side of each triangle is congruent to another three side, right? And this is very basic. And if you look at the SAS, right, the side angle side, one of the most important element that students get confused with is, guys, it is the included angle that is corresponding. SAS meaning two sides and one angle of a triangle, right? So that means two sides, okay, obvious. You can see there's a single strike and double strike, which you can see even in the triangle PQR. But that doesn't matter. It says here angle must be the included angle. What is the meaning of it? That included angle means the angle should be formed or constructed using the sides that are given for the length of, which means ABC angle and the PQR angle. If these two are equal, then only we can say it is a case of SAS, right? Side, angle, side. Right. So moving on to the AAS, that is angle, two angles and one side. And what is the specialty of that particular side, right? And the second and third don't get confused with. AAS meaning there'll be two angles and one side. And also here the side must be the corresponding side of the other, which means you have two angles or two sides, right, with a double stack, right? This side must be the opposite of this particular same angle from both the figures, right? Even though these two looks perfect and look similar, sometimes one will be given upside down and the other one will be given normal, right? So for the understanding, I have given in a horizontal way, right? So don't expect this kind of similar question or the similar thing exactly as it is in the past paper, because that is the application of your knowledge. Here you are grabbing knowledge and understanding and you'll practice the question, and then if you go to the past paper or if you go to the exam hall, then you will apply the knowledge that you have learned, because none of us know how it will be tested, right? Okay, so I hope it's clear the SSS, SAS, and the AAS scenarios. And one of the most important congruency pertaining to a particular right angle triangle is the RHS. Meaning of RHS is that right angle, hypotenuse, and a side, right? A common mistake I have seen from students, when they see a right angle triangle, they blindly comment, right, it's RHS. That is wrong. You need to look for the data available to you and the data given to you. Based on the data given to you, only you need to decide whether this is RHS or AAS or SAS. There are questions in the past paper you can see there are right angle triangles which congruent using SAS or AAS base. So be vigilant to see the data given to you. If you look at the RHS, it must have the right angle. Yeah, obviously we will have that 90 degree in both triangles. Yeah. And the hypotenuse must be equal to each other. And also the other side, right? Cool. So that is the RHS. If you have any question on this, you can drop me a message in a while, not now, right? So we will let's keep going on the area. So I hope I have quickly revised the area of the congruency. And one of the most important thing that you need to use after proving that these two triangles are congruent, we have something called the corresponding elements. Corresponding element. What is that? Corresponding elements. That is, let's say we are proving this triangle ABC and PQR using the data given to us. And we have successfully proved that this triangle is congruent to this, right? And then after proving the meaning, you can place the triangle ABC exactly on the triangle PQR, yes or no? Yeah. So that means even though you are not given about the length of BC, we can say BC is equal to QR, because we have already proved using the case RHS that these two triangles are congruent. Therefore, as a corresponding element, we can say BC is congruent to QR. I hope it's clear for you guys. So that means corresponding element means after proving two theorems using a case, we will come up with some more decisions or some more conclusion using the triangles we have. Okay, cool. So I suggest you guys to have my screen as a half and the shared screen as a half space if you're from a desktop or laptop, right? Okay, so that the explanation as well as the screen share will be available to you. Right. So moving on to the triangles related theorems, right? I have included every single theorem here, right? The most important ones out of the 42 to make sure you need to have a understanding, because there are different level of students in this particular area when it comes to this. There are students who hate this, who are going to love this even after the session, right? So to start with the triangles, right, we have basic theorems in triangles where everyone knows that interior angle of a triangle is equal to 180 degree. That is supplementary, right? And also you should know how to prove this, right? And you have studied this. If not, just try your textbook, and there is a way how to prove this, right? By drawing the triangle and extending and adding a construction over here, right? And also we will be using, so going forward I will be taking you through some theorem related provings as well, because it's not possible for us to prove every single theorem in the session, but I will try to cover as much as possible, Right. So I have enabled the questions, right? Okay. So the triangle. So when it comes to the triangle, the second theorem that we can say is the theorem related to exterior angle and its interior opposite angle. So what is the meaning of it, right? The meaning of this is the exterior angle. Let's say this is 120. The addition of A and B should be equal to the X, that is 120, right? Okay. And then remember that this is your exterior angle and these two are your interior opposite angle. Interior meaning the interior of this and opposite of these two, right? So we say the exterior angle of a triangle is equal to the interior opposite angle. So you will see many questions in your part 1 out of the 25 question related with this, right? So moving on to the isosceles triangles, right? So we can basically classify the triangle based on its side length as equilateral triangle, isosceles, and scaling, right? I hope you guys know this. This is very basic. So EINS, right? That is equilateral triangle where all three sides are equal, and isosceles on the two sides, and scaling different three sides. Cool. So when it comes to this particular theorem related to isosceles, right, it says if two sides are equal in a triangle, the angle opposite the equal side are equal to each other, right? So that means these two are 7, right? And which means these two opposite angles, opposite of 7 is X, opposite of 7 is Y. So X is equal to Y, that is mentioned here. You can highlight. Cool. And the converse or the upside down of the same theorem, they say if the side opposite equal angle of a triangle are equal, which means when you have two interior angles which are equal to each other, 40 and 40, their corresponding opposite sides are equal. AB is equal to AC, that is mentioned here, right? If you need any extra note, you can take this down here while you are revising it again. Cool. Okay, so moving on to the parallelograms, right? So we have covered the basic related to triangles and parallelogram. I would say there is no past paper or no maths paper without testing the parallelograms. If you see, I bet with you, every single past paper has a question on parallelogram, because the significance or the importance of the parallelogram is such. That is even to be more point the properties of the parallelogram or the characteristic of a parallelogram, or what are the features or what are the natures of a parallelogram is what is important. And what is the difference between a quadrilateral and a parallelogram? So quadrilateral, we say the definition, any closed plan figure made up with 4 straight line is quadrilateral, right? Any plan figure with 4 side, and if it is closed, we say it's a quadrilateral, right? So when it comes to the quadrilateral becomes parallelogram, there must be some features which must be satisfied. If you look at, so each of these characteristics must be satisfied to make sure this parallelogram is from the quadrilateral, or this quadrilateral is parallelogram. There are many questions throughout your past paper to prove that this is a quadrilateral or this is a parallelogram, right? So for that, you need to look for 4 features. The features are the opposite sides are equal and parallel. Opposite angles are equal to each other, which means AB is equal to DC, AD equal to CB, as well as they are parallel too, right? Look for equal and also look for parallel and equal. And the diagonal, so what is the meaning of diagonal, right? Joining from one corner to the other corner, this must be a straight line. This is the diagonal. So the diagonal divides the area into equal parts. So which means if this ABCD is 100 centimeters squared, let's say, right? So each of the segment will be 50 and 50, right? You also can draw a particular diagonal connecting DB as well. In that case also you will see two equal portions. So coming to summarize the properties of a parallelogram, opposite sides are equal, opposite angles are equal, opposite sides are parallel, and the diagonal divides the area into two. And also these two diagonals, the blue color and the red color, bisect each other. This must be on the middle, right? So these these three features are the most important characteristic that you need to use to prove that this is a parallelogram, right? I hope it's clear for everyone, guys. Okay, so you please put double star mark or triple star mark on this parallelogram, which is a must for everyone. Even if you are targeting for an S, parallelogram is a must. Please, I don't hope everyone, no one wants an S in the exam, but I'm saying that much important, right? So as you can see, the theorems I have mentioned here, right, straight away from the theorems, if opposite angles of a quadrilateral are equal, then it is a parallelogram. If the diagonals of a quadrilateral bisect each other, bisecting means dividing into two, it is a parallelogram. In a quadrilateral, if a pair of opposite sides is equal, then quadrilateral is a parallelogram. So here, each of these factor is talking about how a quadrilateral can be a parallelogram, right? Because when it comes to quadrilateral, there can be different objects. You can say starting from your square, rectangle, rhombus, kite, all of them are quadrilateral because there are four sides and they are connected. So the special characters that you need to look for when it comes to when you're proving it is a parallelogram from the quadrilateral are these four, right? So you can even take a small summary and paste it somewhere and memorize it. That's a must, right? Okay. So moving on to the chapter chords of a circle. So I just quickly want to show the way how we are progressing, right? I have quickly summarized the triangles and parallelogram and the congruency, right? This is chapter wise summary of your entire grade 9, 10, I would say. Okay, so we are moving on to chords of a circle, angle in circle, and then you will we will go to the questions to be practiced. Okay. So there's a question, sir, can't we use corresponding side or angle instead of corresponding element? Yes, of course, you can use corresponding side or even corresponding angle. For the explanation, I just use one side there, but you can use, so corresponding element meaning anything that you can say after proving two triangles, right? I will give you time for the questions, guys. Right. So moving on to the chords of a circle. Right? What is a chord? It is a line that connects two points of a circle, right? The definition is anyway not tested, but you should know what is the meaning of chord, right? Okay, so chord is anything that joins, or the straight line join any 2 point of the circumference. It can be a chord, or even diameter is the largest chord of a particular circle, right? So there are two theorem that is about the chords of a circle, connecting the center point and the chord. There are two scenarios we can talk about. I have given you two scenarios in the description as well as the the explanation, right? So when you're writing or when you're proving using these theorems, right, you have to write the reason in the bracket, right? Even when you're proving something in the logical order, right? We will come to the 4 steps of a proving theorem in a while, but when you're proving under your 4th step under proof, every single step must be supported with these theorems. So you are not required to write the theorem in detail, right? But at least with short terms, you have to write the reason, because for the reason, you are given marks. Okay. Okay, so let's practice a question and see how it works. So chords of a circle. Chords of a circle, it says number one, the straight line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. That means they are talking about the scenario 2, where we have a chord AB and the line comes from center O to the midpoint of M. If this is the midpoint, M is the midpoint, their conclusion is this OM is perpendicular to AB. OM, it's not, yeah, AM equal MB, and also this AM equal to MB, and at the same time OM is perpendicular, means it's 90 degree, right? So 90 degree for between OM and AB, the straight line, right? That is about the chord. So if you are drawing a line from center to the midpoint of the chord, it is perpendicular. The next scenario says the opposite of it. That means the perpendicular drawn from the center. So the first one, the conclusion was the perpendicular. Here we are starting with the perpendicular. That means we are drawing a perpendicular from the center of the circle to the line. So if you have the center over here, right, if this is perpendicular, that means the chord is getting divided equally, right? Here, if the chord is already divided and the midpoint and the center is connected, we say it's perpendicular. Mark my words, right? And in the next scenario, we say if you connect the center with a perpendicular to the chord, it means you have a bisected diagonal over there, right? Cool. So moving on to the angles in a circle. Angles in a circle. So there's a question in this. Chords of a circle is grade 10. Okay, yeah, fine. So can you explain AAS part? Yeah, I will do that. So can't we, yeah, corresponding element, that's fine. So if four sides are equal in a quadrilateral, then it is a parallelogram. If four sides are equal, it's a square, and also it can be considered as a parallelogram. But in the parallelogram specifically, we say it is the opposite sides are equal, but even square and the rectangle are also having the same characteristics of the parallelogram. Right, so moving on to the angles in a circle. Angles in a circle has three theorems, where we have a circle with a center and with some chords and some diameters, we have three theorems over here, right? So if you look at the theorem, the angle subtended by an arc at the center of a circle is twice the angle subtended by the same arc on the same segment, right? On the remaining part of the circle. So what is the meaning of it, right? If you look at the first scenario over here, right? We have the center O and we have AB, which are on the circumference, right? So here what they say is the y and x are interrelated. How? Because both the angles start from A and ends at B. But the point it touches is the difference, right? This is very basic, guys, but still I just want to make sure everyone understand. I just explained this, right? So the angle subtended on the center is x, right? Let's say this is 100 and the angle subtended on the circumference is half of it, that is 50. So what you can say about this, 2y equal to x, or you can say x equal to, right, 2y, or the other way you can say, right, AOB. So if you name it as C, then ACB twice is equal to AOB, right? So you can write down this particular correlation below this, right? If you have not printed, that's fine. Just note down in your paper and you can get a print later and write down. Cool. That is the first. And remember, so these, now, even though we studied these theorems separately one by one, when it comes to an exam question, as I showed you the paper, right? Almost 4 or 5 theorems got together and it is a combination that we have, right? So we should be able to understand those, right? And also we will be able to understand those only if we have this knowledge in a separate, right? And also these will be combined together in a particular graph, right? That's the reason students feel it is a bit difficult. So if you have the complete knowledge of the theorem individually, then you can have your view or your approach in that way. Cool. So the second, right, the theorem, the angles in the same segment of a circle are equal. Angle on the same segment. So you can see there is a chord here, right? And the segment, the major segment we have is above the red line, isn't it? So remember, let's say this is C, D, and E. Each of these 3 points are on the circumference as well as the A and B. So since the starting point and the end point are on the same points, we say each of these are equal to each other, right? Okay, so this is a very basic one. So where we can say ACB equal to ACB equal to ADB equal to AEB. Yeah, you can write down AEB, right? AEB. Okay, so that is the second theorem that we talk about the angles in a circle, right? Moving on to the semicircle. An angle in a semicircle is right angle. Right angle, that means it's 90-degree angle on a semicircle. So how do we understand it is a semicircle? That we must have a diameter, right? And on the diameter, starting and the end point of the diameter, we need to have the angles. So if let's name them as let's say AB, and we have X, Y, P, and Q, right? Each of these AXB equal to 90, AYB equal to 90, APB and AQB, because each of these angles start with your diameter, that is the half circle, semicircle, right? So semicircle angle is 90. So if you look at the past papers, you will have all these in a combination, right? So we study separately and we will tackle the question as so. You need to have practice on this, right? No point of just going through the theorems alone, and we need to do the question with the combination knowledge. Of course, when you are practicing your past papers, please come back to this note or this tute and then refer to it and go back, because you have limited time, right? So that is the way, only way where you can get closer to these questions, right? So refer to this, and also you can, while do the past paper, and refer to this note, right? Moving on to the next area, the midpoint theorem, one of the most important ones tested in many past papers. Cool. The midpoint theorem. So what the midpoint theorem says, as we have discussed earlier, we have a direct theorem as well as the converse or the reverse of it, right? The upside down of it. Okay, so the midpoint theorem says it is a midpoint of the side of the triangle. So when you see something similar to this in a past paper, definitely it's a midpoint theorem, because most of the paper consists of this midpoint theorem, guys, right? So moving on to the theorem on midpoint, the straight line segment through the midpoint of two sides of a triangle is parallel to the third side and parallel and also equal in length half of it. The two important decisions that we can get, or the two important criteria or the conclusion we can get this midpoint theorem is, when you are connecting two midpoints, right, of two sides of a triangle, that means two sides are parallel. DE is parallel to BC. At the same time, DE is half of the BC. Also, you can say, right? So so you can say BC or DE equal to half of the BC. right? Or you can say BC equal to 2 times of DE as well. So when two midpoints are connected, right, parallel to the next line, so, and also it's half of it. I hope it's clear. And how this can be said in a reverse? How this can be said in a reverse? That is, they say the straight line through the midpoint of one side of a straight triangle and parallel to another side. That means from one of the midpoints, you are drawing a parallel line towards the third side. Okay, starting from the midpoint of the AB, that is the D, and you are drawing a parallel line to AC through the point D, that is the DE. So the conclusion is going to be that bisects the third side into two, right? And these two are parallel as well already. Okay, so that is the midpoint theorem, and we will have to use this in the past papers, right? So let's see how we can use it. But this is a quick revision of the midpoint theorem. So if I summarize, when you are connecting the midpoint of two sides of a triangle, then that is parallel to the third side, and also it is the half of the third side. The converse says when you are drawing a parallel from the midpoint of one side, therefore it bisects or divides the third side into equal, and also it is half of the side we mentioned. Okay, so right, the notes are clear. The equiangular triangle, right? One of the theorem many students get confused with. Equiangular, the meaning equiangular doesn't give you the meaning it is equal triangles. No, that is the most uh, the major mistake done by many students, right? Where equiangular triangle meaning it is not equal, it is proportional. One is proportional to the other, right? One is proportional to the other, meaning now let's quickly read the theorem and go down, right? A line drawn parallel to a side of a triangle divides the other two sides proportionally, not equally. Proportional means, right? Proportional doesn't mean it's equal, right? So proportional is, now say for example, if you really want to understand the proportional, now say for example, a particular boy is 5-year-old and a girl is 10-year-old, right? So depending on their needs, if father is going to give a particular amount, let's say, depending on the age, if he is going to divide, the son is getting 10 rupee, the daughter has to get 20 rupees. That is proportional to their age. So likewise, if it is proportional, right, it doesn't mean it's equal, right? And we have to write the proportional as a ratio, not with an equal sign, right? So converse of the theorem says if a line divides two sides of a triangle proportionally, then that line is parallel to the other side. So this is somewhat connected to the midpoint theorem as well, guys. So you can learn both the midpoint theorem and equiangular triangles together and have a complete understanding of it. It is mostly, when it comes to question, it is testing both, right? Okay. And the theorem on equiangular triangle, it says if two triangles are equiangular, if their angles are equal, the corresponding sides are proportional. That means you can have a small triangle as well as a big triangle, right? So let me use the whiteboard for a second. You will be having a larger triangle as well as a small triangle. So we can't say that these two triangles are equal. But with the side, we can say, let's say this is your ABC triangle and this is your PQR, right? We can say ABC triangle is proportional to PQR, which means the side AB can be proportional to PQ. And we can say the side BC is proportional to QR. And finally, the AC is proportional to PR, where you can starting with you can start with the ratio, and then you will moving on to write this as a fraction, and then vice versa you can do the questions, right? So here what you need to understand is AB can be written as AB over PQ, BC over QR, and AC over PR, right? So that is about the equiangular triangle, where since their angles are equal, if ABC equal to PQR, and this is equal to this is equal to this, that is equal angle will give you the triangles, or will make the triangles corresponding. Okay, and these two are not congruent as well. So these two are similar plane figures, where you can have one as a ratio of the other. Cool. Right. Right, there are a few questions. Let's quickly sort it out. So yeah, I'll move on to cyclic quadrilateral. So so how many theorems are there in cyclic quadrilateral? There are 3, 4. We will come back to that. So sir, can you explain the third one again in the chords? Right. So can we use SAS to prove the congruency of a right angle? Yes, of course. SAS can be used to prove, and also AAS also can be used sometimes, right? Because that is purely depending on the data available for us in the question. So, sir, can you explain what are corresponding elements? Now, corresponding elements mean, now, for example, guys, let's say my two hands are corresponding. Let's say I can place one on the other using 5 fingers, let's say. Using 5 fingers, I'm saying these two hands are corresponding. Cool. Then after saying using these 5 fingers, if my hands are corresponding, then I can say maybe the weight of my hands are equal, right? The size of my hands are equal, right? And the appearance of my hands are same. So similarly, you can use the triangle, and you can use the case SSS, SAS, AS, and RHS. And after saying that they are congruent, right? Because for the case, we have only 3 elements, right? SSS, AS, or SAS, or RHS. So we use only, at least we need 3 evidence to say that these two triangles are congruent, isn't it? But after saying 3, using 3, we can say all the other elements are also equal to each other, right? Okay, right. So can you explain the proportional part? Yeah, so cool. I'll come back to that in a while. Right. So the proportional, if you look at the tute, right? So we have some question. Yes. Right. So when it comes to the equiangular triangle, as you can see, there are 3 boxes given to you, as you can see, right? The AB, AD, right, is proportional to DB. And they say, right here, it must be AE over EC. There's a small typing mistake. That's okay. Okay. So anyway, this part is right. Okay. So you can make a difference, right? So D is parallel to BC, and AD over DB. This AD over DB is parallel to, or the proportional to, AE over EC, right? Also, you can see here AB over PQ, where AB is this side and PQ is here. AC over PR, right? BC over QR. That means these are not equal. They are proportional. Okay. Cool. And moving on to the cyclic quadrilaterals. Now, what is cyclic quadrilateral? We know quadrilateral is any figure with 4 sides. It's a closed figure. And we are, right, inscribing, or we are making a circle outside the quadrilateral, or we inscribe a quadrilateral inside the circle. But it is a must that you need to know, when you are having a cyclic quadrilateral, all 4 vertices or all 4 endpoints of the quadrilateral must be touching the circumference. That is the line on the circle. So cyclic quadrilateral means cycle and a quadrilateral, a circle and a quadrilateral are combined together. That is a cyclic quadrilateral. So we have some interesting theorems on cyclic quadrilateral, which is heavily tested in the past papers, right? So when you look at the theorem, the opposite angle. So I have given enough space here to write. If you have not printed, guys, I'll write on a paper, and also you can write this later on the print. Okay, cool. On the cyclic quadrilaterals, right? So we have a quadrilateral here, A, B, C, D. If I name or using their angles, and we have a circle as well, right? So the if the opposite angle, so they say the opposite angles of a cyclic quadrilaterals are supplementary. What is the meaning of supplementary? It is supplementary. Complementary is 90, supplementary is 180, right? So that means the opposite angles, right? So A and C, these two are opposite, right? So below the diagram you can write A plus C must be equal to 180. Same way you can say B and D, this the opposite of the cyclic quadrilateral. Guys, you can see all four vertices are on the circumference. There are some confusing questions in the past paper where they have given 3 points are touching the circumference and the other side is not, right? So be vigilant on that, carefully look at, right? Okay, if possible, try to do this question, this theorem related question at a stretch. Take like 2-3 hours, sit in a place and keep doing, and have my tube printed with you and keep practicing. And also, as usual, I have given you the analyzed version of your entire past paper related to this. It's having 10-year past paper analysis where starting from 2010 until 2019, right? You can see every single year has two question. You can see two question on 2010, 2012, every, and also I have mentioned the description, right? So where which particular chapter is tested on, right? This has taken a lot of time for me to analyze, but I know it is really a value addition for the students, right? So you can see all the congruence part here, and you don't need to look around your past paper. Just go and to that specification, do it, compare with the answer, or if you have a question, ask with me or ask with someone, and then get it cleared then and there, right? Because you have a limited time, right? For the grade 10 students who are at, online, right? We will be learning this throughout our class series and the sessions, right? So okay, also I have included the summarized version of this in the final seminar series as well. Cool. So moving on to the cyclic quadrilaterals, right? The second part. So I hope the opposite angle part is clear. A plus C equal to 180. Similarly, you can say B plus D equal to B plus D is equal to 180. So please write down this, guys. B plus D equal to 180, right? Mark my words, okay? Not the something that I'm scribbling on the screen. The second part they say, now how we can say it is a cyclic quadrilateral? If it is a cyclic quadrilateral, see I have bolded these, right? Highlighted all four A, B, C, D points must be on the circumference, right? So if you can see there's a quadrilateral which has all four vertices on the circumference, then it is a cyclic quadrilateral, right? So if the opposite angle, so not that, right? So if one, yeah, if the opposite angles of a quadrilateral are supplementary, then vertices of the quadrilateral are on the circle. So that is the upside down or the converse of the theorem, right? So it must be. So if the opposite are equal, let's say if B plus D equal to 180, then it is cyclic quadrilateral, and also its vertices are on the circle. So this is a feature of the cyclic quadrilateral, right? And the third theorem, if you look at, so here you can say if B plus D equal, B plus T equal to 180, then ABCD is a cyclic quadrilateral, and ABCD are on the vertex, right? Okay, so you can write down that later. The third, right? If one side of a cyclic quadrilateral is produced meaning extending outside. Also, you must have seen this in your triangle as well, something related to this, right? Produced or extended, the exterior angle so formed is equal to the interior opposite angle. So slight different when you compare with your triangle theorem, but don't get confused with, right? Here in the cyclic quadrilateral, what we have is, guys, the exterior angle is equal to its interior opposite angle, only the opposite. That is, you can say CBE equal to ADC. Don't get confused this with the triangle theorem, where in the triangle we have, I'm just mentioning here to avoid confusing, the exterior angle is equal to two interior opposite angle, that is in the triangle. Here, it's only the opposite angle. Okay, cool. So I hope this is also clear, right? This is heavily tested with the tangent question, right? The cyclic quadrilaterals are mostly paired or mostly combined with the tangent question, where we will be moving on to the tangents now, right? So what is a tangent, guys? Right? You have any question you have, you can put it on the chat box. Tangents. Tangent is something, a straight line that comes to a circle from an external point, which touches only a single point on your circumference. It can't interact inside, or it can't go through that circle, or even it cannot go outside that circumference without touching, right? So if you look at this, is a tangent where it goes outside through, but it touches only a single point on the circumference. You'll see it has to touch only a single point. And we have major two type of theorems related to it, right? Moving on to this, where when you draw a line or connecting line from center to the connection point, it says it's 90 degrees, it's perpendicular. Or even if you write the other way, if you say the converse of it, if you join the A and the C, I mean the point of the tangent joining the circumference as well as the point of the center is perpendicular, right? So let's quickly have a read on it. Theorem: the straight line drawn through a point on a circle and perpendicular to the radius through the point of contact is a tangent to the circle. So here they are describing what is a tangent, right? Obviously the definitions are not tested in maths, very rare, but if it is a tangent, you need to know it is a line that has been drawn. So guys, kindly keep your microphone muted, right? Keep your microphones muted. Converse of the theorem says the tangent through a point on a circle is perpendicular to the radius drawn to the point of contact. So point of contact means this, the A point, where the circumference contacting the line that comes from outside. Okay, cool. So here what you need to understand, if I summarize, the line that goes outside touching one single point is perpendicular, or it's 90 degree, and mostly you will have to use your knowledge on Pythagoras to find the length of this, right? So I have included some question on this session. We will work on that.
Can you say one more time?
So if you have any question, guys, please leave me a question, leave me a chat, right? Or a text message. Keep your microphone muted, because that might...
Can you explain one more time?
Right. So the tangent, right? If you look at the tangent theorem, right, just one last time, right? What you need to understand as a summary is the line that comes out, or the tangent, the contacting the point A, right? And the line connecting the point of contact and the center is perpendicular, right? Let's say this is your XY axis, XY line. So we would say XY is perpendicular, XY is perpendicular to AC. That is the summary of this particular part, right? And then we have another theorem with two tangents. When two tangents are drawn from an external point, how this is going to look like, and what are the conclusion we can say, right? You might have seen this, and this is a familiar one. And if it is tested, obviously you should be able to get the marks, right? Because this is not that complex as the other theorems, right? Okay, so let's have a quick read. If two tangents are drawn to a circle from an external point, not from two external points, from just one external point when you are drawing two tangents, because from an external point maximum of two tangents can be drawn, right, touching two contact points. So then now these Roman number 1, 2 and 3 are the most important ones, right? So I have given enough space for you guys to take down the summary of the discussion, right? Cool. So this Roman number 1 says the two tangents are equal in length. That means AC is equal to BC. AC is equal to BC. That is because it is from the same point and from the same circumference, isn't it? Right? So AC equal to BC is 1. Number 2, the angle between the tangent is bisected by the straight line joining the external point to the center. That means they say, now let's say this is O, the line OC bisects this angle, the ACB, which means this is equal to this. So we can say ACO equal to BCO.
Sir, Roman number 2, can you explain one more time?
What is your name?
My name is Rishda.
Yeah, can you please mute your microphone and put the question on the chat box, because there are many people listening. Okay, right. Right. So ACO equal to BCO. BCO. Okay, so the first feature they say, the first conclusion, the two tangents are equal in length. I hope you understand this. AC equal to BC, because C is the fixed point we have external, or we have outside the circle. So it comes, so definitely this must be equal to each other, right? Because it's from the same point, external point to the same circumference, right? Because the radiuses are equal from the center to any part of the circumference, isn't it? So that's the reason why AC equal to BC. That is the first Roman number 1 that we can talk about, right? The Roman number 2 is about the angle we have here. The angle ACB, right, is bisected through the line that we draw from C to the center, right? That is the second. Roman number 2 says the tangents subtend equal angle at the center. So that is the vertex, this vertex. So that means if I use a different color over here, right, this angle is equal to this. That means AOC equal to AOC equal to BOC. That is your Roman number 2. So please write down, guys, if you have pen and a paper, right? So that is about the theorem on tangent, right? So these two are the most important two theorems, right, on tangents, right? And basically we can say, right, these two triangles, I mean the triangle ACO and BCO are congruent. This triangle is exactly congruent to this. On what case? On what case? That is depending on the data given to us. So since this is a right angle triangle, we can't say this is on RHS. That's the important point I just wanted to pressure you guys. Okay, cool. So I hope you guys are clear from whatever the theorem that we have discussed so far, right? So what I have given here is the most important theorem explained with a diagram, right? But however, there are like 40 to 45 theorems which has been listed out here in sentence, right? So it says geometry theorem grade 9, 10 and 11. It is a summary of the theorems which we have listed, right? You might have seen this from different places, right? But this has everything starting from 1 to up to 28 up to 42, right, guys? Please take time, sit in a place, right? And you have got a very valuable document with you in your hands now, and work on it one by one. You can work on it, because every single theorem, the 42 theorems, will bring you about, like, if you do both question in your part 2, and then 20 marks. And of course there are like 3 or 4 question in your part 1, which means like 25% out of 200, right? So that is a very significant number for you guys, right? So those who have a mindset, I'm not going to do that question, I'm going to skip one of that, don't go with a prejudgment to the exam hall, because we never know what kind of trigonometric question is going to be there in the question. Sometimes if you don't get the idea for the trigonometry, right, for the graph, right, if the graph is in a part, that's okay. So if you don't get the idea on the construction, then you are compelled to do both the question on this. So you have enough time, guys, right? Keep yourself motivated and be prepared. And if you have any doubt, we are there, and your friends are there, your teachers are there. So make sure you get the doubts clear before you go to the exam hall, because the 2 questions is a must in the exam paper. Without that, we won't see a 2020 paper, right? Okay. So most of the important theorems have been already discussed, and the small ones, like, right, start with the first one, angle at a point add up to 360. So the angle, acute angle, right angle, all these very basic stuff have been listed here, but that's very important, right? What I can suggest from this 42 list, guys, sit with a paper and try to draw your diagram for each of these, starting from 1 until the end of 42, right? Draw and have some paper and keep drawing until 1 to 42. Definitely your paper is going to be consisting of these 42 theorem. Out of the box, they can't test, because everything have been almost, I am 99% sure I have included everything relevant to your O-level syllabus, right? So the document you have is very important and valuable, as I guess, right? Okay, fine. So since we have a 10-minute for this part, right, let's quickly have right steps in providing a theorem or proving a theorem, right? So now when it comes to proving a theorem, right, in an exam, right, they will say show that AB is equal to CDE, or they don't only look for the word prove that. They might have come with show that or prove that, right? Okay, or you can say conclude that. So those kind of question requires a proof for you to prove. Out of the 42 theorem, not all 42 can be proved with a logical, but there are certain things, right? So I have included 2 theorems that to be proved, right, for you to just get the idea, right? Okay, and yeah, so when it comes to a proving theorem, guys, there are 4 steps, right? 4 steps, out of which the third step is an optional, because you don't get it for every single one. So the data to prove that, we say TPT, and construction and the proof, right? If you look at the past papers, right, these proving questions bring you a lot of marks, right? If it is a 10-mark question, for that show that a proving question, you will have like 7 or 6 marks out of 10, right? So now what is the data? So you need to start with data to prove that. These 2 are like very bonus marks, or at least you are given for data and prove that, you are given at least 1 or 1.5 marks in the exam, which is a bonus. What is the data then? Data means whatever the diagram you can see from the question, write in sentence. If you are given a circle with a diameter, then you can say circle with a center has a diameter of AB. So just write whatever you can see, whatever the data given to you, write in sentence, then you get 1 mark, most probably. And then you grab 1 mark even without knowing anything, right? 10% cover, 10% of that particular question is done, 1 mark. So to prove that, what is the proof that? To prove that, straight away go to the question and see what are you going to prove. So it's the question that you're going to do, right? So what are you going to give the answer is for their question. So the question is your final answer. So copy that question to the prove that, but don't just copy if it is a paragraph, right? You will waste time. But in summary, you are going to say, this is what I'm going to prove, and make sure your proof ends with whatever you are going to prove, right? For example, if you look at this theorem, right, which is with the tangent, guys, you can see the data first, right? You can see PA and PB are tangent. So we know that, right? PA and PB are tangent. It's obviously you can see, this is what you can see from the question, right? To the circle of center O, right? From an external point P, A and B are the points of contact. That's it. So that's all you can see from this, right? PB and PA are the tangent. P is an external point and O is the center, and B and A are the point of contact, or the contacting points, right? Or the touching points. So you can use your own language, but English, right? Okay. So I mean the writing language. So guys, so the data is clear, right? To prove that, that means in the question they will mention show that, show this, or to prove that. Just copy that here and make sure you arrive at that to prove that sentence at the end of your construction proof, right? The third say the step is your construction, right? This will come with your practice, right? You can't memorize for which theorem we have to do construction, for which theorem we can't do construction. It comes with the practice, because it's with the idea, right? If you think, okay, when I am drawing the dotted line from this point to that point, then I would get the idea, go and do that and mark it as a construction, right? So there are some ideal theorems. Now, say for example, if you want to prove, right, as I discussed earlier even, right, if you have a circle, triangle, and if you need to prove that these interior angles are equal to 180, then of course you will do a construction. You will extend the line, and also you will draw a parallel line to this through this point, right? Okay, so these two are known as the construction. So whatever the dotted line, the additional part that you are adding on to the given picture or to the given diagram, make it as a construction. That is optional. Sometimes it might not come. Cool. And the proof. What is a proof? This is the major area. If it is the whole thing is for 7 mark, you get 1 point mark 5 here and 1 mark here, that 2.5 goes, and the balance 5 marks or 4.5 marks is for the proof. So how to start a proof, guys? It is not always with a trigonometry or with a congruency, right? Before you do, or before you start writing the proof, right, please get the idea. Okay, this is the way I'm going to write. Please don't start right and then think, then most of the time you will go wrong. So get the idea, right? This is okay, because of these two are equal, okay, and the reason is this. So write the reason within bracket, so to have a pre idea of answering. Otherwise you will get stuck, and also you will waste a lot of time in this, because exam is all about doing or showing your game within the time you have, isn't it? So right, and you need to know how to, so, and also we will discuss more exam oriented techniques, how to tackle marks, how to get more marks in the final series. So this is the same as revision, so that we will focus that in the final seminars, right? So proof will have to be given with a logic. What is meaning a logic? Logic or reasons, right? And you need to give evidences. You can't just say that is equal to this is equal to that, because you need to use all these evidences, right, to show that this is equal to that, or this is the conclusion because of that. So I will come to a question and we'll practice on that. So if you look at this particular proof, right, so they say in triangle AOP, BOP, OA equal to OB, this is a radius, right? OP is common, and they say the bracket within bracket, right? The reason within bracket. So therefore, according to the above congruency, right, they come up with a congruency and say RHS. So these are your proofs. You can see the final proof and the to prove are exactly same, matching. So target your to prove that until you end with that, with the proof that you are doing, right? So that, so, and also I have given you one more, right? Right, also you can go through this later on, right? So the data is there, data is just writing whatever it is to prove that whatever the question we have. Construction, that means join a triangle OAP, so that means we do this basically, right? So you use, based on that we will be answering, we will be coming up with a congruency, and then we will write the reason within bracket. For writing the reason, I highlight the marks are allocated, guys, right? Okay. And also there's one more theorem, right? So you can go through that as well. So right, so the geometry part is very significant, right? So let's do a quick question, right, from one of the model papers, right? Since okay, we can manage with the time. So, and what I humbly request from you guys, sit with the past paper and a paper, do all this question if possible, because you have enough time, right? So 2010 to 2019, everything is in your hand. It's up to you whether you guys are going to use it or not. It's up to you completely, right? But try to make sure that you get the benefit of this table, right? And also you can do for others as well, right? Okay, right. So guys, look at this particular question. I hope everyone can see, and I can give you like 1 minute if you have any question in this. So, sir, can I, yeah, please, can I have the tute? The tute has already been circulated, guys. You can get it from another friend, or just drop me a WhatsApp message. I can send you, no problem. So, can you do past paper question with us, right? The necessary step provide, yeah. So, we'll do proving one question, right? Sir, your number, or maybe you are from unregistered person, right? So please ask from one of your friends, or 07761671118. Okay. So guys, I hope you can hear me, right? So there's a message from someone that can't hear your voice. You can hear, right? Someone please confirm, because I just want to confirm, because there might be some technical issues, right? Okay, fine. Okay, thank you. Sir, to find the perpendicular, sir, to find the perpendicular value, we have to add the value. Sir, to find the perpendicular value, we have to add the values. I mean, the question is not that clear. Please drop me a WhatsApp message. I will clear personally, right? Okay. So someone has, yeah, sent the link as well. Wait, I'll copy and paste to someone. Right. Okay. Let's look at this question. This is a question from the NIE model paper series, which we use to practice in our class series, right? It has 7 papers and complete model papers given by the NIE, right? That's in 2017 or 16, right? So we used to do that, the complete 11 papers. So I just picked just one question relevant to this, okay? The diagram shows a cyclical quadrilateral. So guys, can you quickly read and start doing this until I just quickly copy this particular question on the whiteboard, right? I'll give you a few minutes, okay? Just quickly have a read and start doing this, right? Well, let's have like 2 minutes for this. There is a circle over there, and we have the center. So those who are done copying, you can start doing it now. I hope the whiteboard is clear. I will stop share once I'm done drawing this, okay? This is OK. We have AB, Okay, AB, and also we have a tangent which touches the point A and B. All right. So the question they ask, right? The diagram shows a cyclic quadrilateral A, B, C, D. Cyclic quadrilateral A, B, C, D inscribed in a circle of center O and radius 17 centimeter. So that means the radius is 17 centimeter, right? So I stop sharing. So what are the conditions in RHS? Yeah, please look at the tute, right? And if you are not in a position to understand, please leave me a WhatsApp message and I'll clear personally, because we might run out of time if I take those headings again, right? Because we have limited time. Okay. So if you look at the question, right? I hope you guys have the question with you, right? So this is diagram. So they say the diagram shows a cyclic quadrilateral ABCD inscribed in a circle of center O, radius 17 centimeters. So we have the radius 17 centimeters. So both the side you can see 17 centimeter. Whatever I can read from the question, yeah, guys, what you need to learn here is the way how you tackle, or how we are going to start writing the answer for this, right? While you are reading, and we will jot down whatever the values and the measurements we are given with. Okay. So this question is not from the tute, guys. It is a question from NIE model paper. I just wanted to select and do, right? This is not from your tute, right? So look at the diagram on the whiteboard. I guess you guys can clearly see that, right? Right, the diagram shows a cyclic quadrilateral ABC, radius 17 centimeter. If the length of the chord AB, if the length of the chord AB is 16 centimeter, so they say 16 centimeter is the chord, the entire length, 16 centimeter, right? Find the perpendicular distance from O to the chord AB, right? So guys, what you need to understand, or what you need to use, is one of the theorem that we have discussed already, right? That means they say if the length of the chord is 16, this is 16, right? Find the perpendicular distance from O to AB. That means they are asking you to find the length OK, this, right? For this, what you can use, the chords of a circle, right? We have discussed this in detail. That means when you connect, or when you draw a perpendicular, because they have already mentioned this is a 90-degree perpendicular. When you draw a perpendicular from center to the chord, that actually divides the chord into two equal parts. This is there in your tune, right? And therefore you can say what is the distance between OK, right? So that's what you need to find for. So for that, since we have found that these two are equal, I would say this is 8, this is 8, right guys? And also we are given of this particular, you can even approach using this left hand side right angle triangle, or the right angle side. So for the question, let me use this particular right angle triangle, right? Since we have already found the value of KB, that is 8, half of the 16, because of the angle on the chord, or angle chord is 16, therefore it is 8, right? So to find the value of this, the OK, we need to use the Pythagoras theorem, isn't it? So we need to use the Pythagoras theorem. So applying Pythagoras theorem, so I'm answering the question number, Roman number 1, right? So let me write the question, and then I will erase because of the limited space available for me, right? So I would say OB equal to 17 centimeter, OK equal to unknown, that we don't know. That is what you need to find for. And also we know KB equal to 8 centimeter. That is because of the midpoint of chord, right? So we write the reason in summary, all right, or in short. So we say applying Pythagoras theorem in triangle, I would use this triangle OKB, right? We can say what is Pythagoras theorem, everyone knows it, right? So the square of the hypotenuse is equal to, write the addition of the square of the other two sides. Guys, don't try to write the explanation of the Pythagoras theorem. You will definitely waste the time. Okay, so make sure, right, applying Pythagoras theorem. So we can say OB squared equal to OK squared plus KB squared. All right, that's more than enough. OB, you know already, that is 17 squared equal OK, that is the question we need to find for, and the KB squared is 8 squared. Guys, we found the 8 by taking the half of the 16 because of the midpoint of the chord, because this is perpendicular, right? That is the reason, and also we have mentioned it. So 17 squared minus 8 squared equal to OK squared, right? So 17 squared minus, so 17 squared minus 8 squared, right? So 17 squared, so 17 minus 8, 17 plus 8. So whatever the method you use, it doesn't matter. So we get OK squared equal to 17 into 17 minus 8 into 8. 17 into 17 minus 8 into 8. So I'm using a calculator to save my time. So 17 to, so it's 225. OK squared is 225, not the OK. What we need to find is the length of this OK, the distance between the diameter and the center. That's a question number 1. So square root 225 would give you the OK, right? So OK is 225, square root is how much? It's 15. So I guess OK is okay, isn't it? So I'll give you like 1 minute for you guys to copy or just to quickly take a screenshot of the working. That is for the first. And also I can share the question once the seminar is over. Just drop me a message, right? I can share this as well. Or if you have the NI paper, model paper set, that is the question number 11 of the paper 2, I guess, right? So that's the end of this. So we have found that the OK is 15 centimeter, right? That's the end of the first part. If you look at the question number 2, they say, Roman number 2, I will write the question. If you, it's in the, this is very short. Find ACB if AOB equal to 58. Right. So we need to find the ACB if, right? We need to find the ACB if AOB equal to 58. So where is your AOB, right? Where is your AOB, right? Your AOB is 58, right? And also we have not yet connected this, right? So if I look at the picture, there's a line, right? Let me share the screen for now. Just we are running, we might run out of time if I keep sharing it. Okay, this is the question, right? This is your AC, right? The AC. So we know this is 58 and we need to find the ACB. Guys, we have studied in our tude this theorem. This is the theorem in which this particular question is tested on. This, the first one, where the angle subtended on the center is twice the angle on 50, or the circumference, right? That is a similar question that we have in this particular question, where the angle subtended on the center, that is here, the AOB equal to 58 and ACB is going to be half of 58. I hope this is clear. So therefore we can write ACB is half. So we can say, how are we going to write the description? Because examiner always looks for the way how you got the answer, right? Because this is not a part 1 question, right? This is a part 2 major question. So therefore, guys, you will have to write AOB equal to 58 degree, right? Therefore, ACB equal to half of 58. Or you can say even half of AOB. What is the reason? You have to write the reason now. Angle subtended on circle is twice of the angle on the circumference. So this is a must. Or if you find any way you can make this shorten, or you can write this very in short, that's okay. Go ahead, no problem. All right, cool. Okay, so therefore we can say ACB equal to, what is half of 58? That is 29. Equal to 58 degrees. ACB equal to 29 degrees. So it's 29. Half of, right, 58. So guys, please keep your microphone muted. A humble request. Right? Okay, so ACB equal to 29. So that's the answer for the second part, right? So let me quickly get rid of this. The question number 3 is talking about find BAD. This is the question number 3. Find BAD if AOB equal to ACD. Right. So this is a good one, where we are required to use one of the theorems, right? So they say AOB equal to ACD. That means AOB, that is 58, is equal to ACD. So this is also 58. Okay, this is 58. They say this is equal to that, right? So since these two are equal, we need to find the BAD, where the BAD is. So we need to find the BAD, the entire one. And remember, guys, this ABCD is a cyclic quadrilateral. So here we are going to use the cyclic quadrilateral theorem now, right? So how to use the cyclic quadrilateral theorem? Now we have, right, this is the one that we need to find for, right? BAD, the whole thing, right? So since the cyclic quadrilateral has a theorem that their opposite angles are equal to 180, right? So I repeat the question, guys. Please keep the microphone muted, please, kindly. Find BAD if AOB equal to AOC. Right. So we can say AOB, right? The AOB equal to 58, right? And also that is equal to ACD as well, right? That is also equal to 58, right? That is the first step we can say. So therefore, ACB also equal to 29, right? This part and this part have been mentioned already, right? So therefore, we can say, therefore, BCD equal 58 degree plus 29 degree, that is 87 degree, right? And we know the cyclic quadrilateral theorem, that is the opposite addition of the opposite angles are supplementary, meaning it is 180. So therefore we can say we need to find the BAD. So therefore BAD equal to 180 minus 87, that is 93 degree. 93. So here we need to write the reason. Please write the reason over there. What is the reason? The opposite angle of, or the sum of the opposite angles of a quadrilateral is 90 degree, or you can say supplementary. I can give you like 1 minute to copy this. So here you need to say or mention the reason for that. So guys, this is the thing you need to get from the way we do the question, and the skill how to tackle a question and how to give the reasons in a proper way, right? Because every single step has a mark. Even if you do numerical mistake, now let's say for example by adding 58 and 29 you put, let's say, 97, that doesn't matter. Even if I am, yeah, if I am a examiner, I'll try to give you mark, because that is the additional mistake you have made, but you know the technical stuff, right? So guys, don't make these kind of silly mistakes, by the way. But still, if you have included one by one, and don't be we don't try to be even genius, like writing the exact final answer without skipping all this, right? So don't try to do that as well. Try to mention, like, for a small children how we are going to explain, so likewise try to explain this, right? Okay, so the last question of this is, they say, if the lines touching the circle at points A and B meets at T, so these two are the touching points, they say this is their outside. So that is the theorem that we just see, discussed, right? So write the relationship between AT and TB. State the theorem on which it is based. So if I screen share, guys, if you know, right? And when there are two tangents drawn from an external point, we know that these two are equal to each other, isn't it? And also we have some other elements as well. So if I mention, or if I show that exactly from the tude that we, or the question that we were discussing, it's here, right? So here the AC equal to AB, oh sorry, the BC, the Roman number, that one that we discussed is the question that we just did, right? So therefore the final answer you can say for the Roman number 4, right? AT equal to BT. Reason, right? When two tangents are drawn from an external point, the distance are equal, or they are equal to each other, right? I guess the way how we did the question has given you some insights, and when we practice more and more questions, obviously you will get some more insight on it. So please sit with the past paper and do a good job, right? And also we will do like 5 or 6 questions on this in the seminar series of the final. We are to cover up the syllabus, right? Cool. And yeah, I can give you like 1 minute or 2 minutes, right, for the questions, guys. I can give you 1 minute to wrap up this particular session on theorems and this particular area, right? And then we will move on to the constructions. Right, so the time is also running, so right, so we will share the question through WhatsApp, right? So share question, please. Yeah, we will share through WhatsApp. Just leave me a message, then we can do. And also there are many questions in the question bank as well, right? So we can share that as well. So okay, guys, so if you have any question, then you can contact me personally, then I will be helpful for you guys. So I hope with this we can end the area relevant to this particular theorems, right? I hope you guys got some insight, right? My happiness is if you guys at least got a very good understanding, and at least if I have made you guys I have made enable you guys to at least get like 10 or at least 5-6 marks in the past paper or in the question paper, that's my happiness, right? Okay, so we are happy with that. Okay, so okay guys, let's take like a 2 minutes break, right, to start the constructions. Okay, so for the time being, so please don't unmute or don't leave the class, just stay as muted. Okay, I'll join back in 2 minutes. Okay guys.